So the first thing I'm going to have you do is open your notes to this one we didn't get to yesterday, so you might have to search it because I don't have the pages numbered. And we're going to use our definition of the derivative that gives us the slope of the tangent line any place along the curve of f. And our function in example 1 is the square root of x. And I want to determine what the derivative is on that curve for any x value. So what I'll do is I will take the limit as h approaches 0 of f of x plus h. That means x plus h goes in as the input to x. So it'd be the square root of x plus h minus f of x, which is just root x, all over h. Now you notice when I plug 0 in, I get 0 over 0. I get root x minus root x over h, which is 0 over 0. So I need to clean this up. And we talked about in our chapter 1 that a lot of times when you get that 0 over 0 indeterminate form, multiplying by a conjugate, where we just change the link between those two terms, helps clean that up. And it still does. So I'm going to multiply the top and the bottom by the conjugate there of the top. When I FOIL the top, that's not an equals to sign, by the way, I was underlining that. When I FOIL the top, I've got my limit as h is creeping up on 0 of, and then I have my x plus h when I do my firsts. Outsides and insides always cancel with conjugates. My lasts are root x, root x. On the bottom, when I multiply these two, I've got kind of a mess, but that's okay. It'll clean itself up here. My marker's just on a pause. There we go. Root x. All right, when I clean this up, notice these x's cancel, and so do the h's, which leaves me a 1 on the top. And now as h approaches 0, I'd have the square root of x plus 0 plus root x. So on the top is a 1, and on the bottom is root x plus root x, or 2 square root of x. This is the derivative of the function at any x value, which means it gives us the slope of the tangent line anywhere along the curve. So if this is 4, I would have my slope of the tangent line being 1 over 2 root 4, or the slope of that tangent line is equal to 1/4. And we did that yesterday. So now what I want you to do is take out a blank sheet of paper, and we're going to work on starting our worksheet for today, which you're going to do on a separate sheet of paper. So take out a separate sheet of paper, pause this video and make this table, and then we're going to go do one together, and then you can just finish on your own. So we have two forms of the derivative. We have the definition of the derivative, which gives us the slope of the tangent line at any x value, technically in the domain of f, but we'll write at any x value on the curve. And we derived that yesterday, so if I had this function right here and I called it f, your limit process, given right here, will find the slope of the tangent line anywhere along the curve of f. Okay, so I don't know why it's not drawing. Please don't be dead. Oh, there we go. So this will give me the slope of the tangent line anywhere on the curve of f. Maybe I want to know at -1. Plugging a -1 into the function that I get will give me the slope there. Plugging this into the function I get will give me the slope there. Plugging this x value in will give me the slope there. The alternative form, in our notes yesterday, I think we used a c for constant, but just so to know that c is a number. So it'd be like the limit at x approaches 2 of f of x minus f of 2 over x minus 2. This gives me, let's go ahead and up here write f prime of x. This gives me f prime of c. What's the difference? This is the slope of the tangent line at specifically x equals c, or in this case, at x equals 2. So this top one is much more powerful because it gives us the derivative at any x value. This one just gives us the derivative at a specific x value. So on a separate sheet of paper, hopefully you wrote that down, we are going to go take and grab number. Oh, by the way, let me give you your assignment first. We need to do number 1. You need to do number 2. We're going to do number 3 together. You're going to do number 4. You're going to do number 5. And then by then that's enough, so we'll skip number 6. And we're going to talk about 7 and 8. So actually your assignment's going to be 1 through 5 is what you're going to need to turn in, with 3 being the first one you do because we're going to do number 3 together. All right, so with number 3, it says, find f prime of x. Okay, so that's our limit as h approaches 0 of f of x plus h minus f of x all over h. And my function for number 3 is 1 over x minus 1. All right, so let's just go put our x plus h in for x, and we would get 1 over x plus h minus 1. That's f of x plus h, check, minus the function itself, all over h. Now, I have a notation problem with mine, and I'd like you to look at that. Remember, we don't drop the limit until we are at the end. We'll go like this. Now, if I put a 0 in for h, I'd have 1 over x minus 1 minus 1 over x minus 1, which is 0, over 0. So from last chapter, we have to remember, what did we do when we had complex fractions? And that's when we did the criss, then the link, which is minus the cross, all over multiply cross, and then it collapses as a product. So we need to go do our little algebra move with that. So we're going to say x minus 1 minus x plus h minus 1 on the cross, all over multiply across x plus h minus 1 times x minus 1 collapse as a product. It was all over h. It's a limit as h approaches 0. Now I need to clean it up. My x minus x is gone. My negative 1 plus 1, because it'd be minus and negative, is gone. And I end up with a negative h. So all that's left here is a negative h over this stuff. But the negative h is going to cancel with the h on the bottom. And it's going to leave me with negative 1 over x plus h minus 1, sorry, I'm running out of room, times x minus 1. It still was a limit, and we still had h approaching 0. And when I go put a 0 in for the h, I get negative 1, so I'm going to write it over here because I'm running out of space. F prime of x is equal to negative 1 over x minus 1 quantity squared. That's part A. But also in part A, that's why I'm only assigning the 5 of them, of which I'm doing 1, so I'm assigning 4, because I really want you to understand what you're finding. I just found f prime of x using the definition of the derivative. What does my answer represent? So for part B, you're going to say that this is the slope of the tangent line for any x value on f. Actually, you got to be a little careful for any x not equal to 1, because 1 wouldn't be in that domain. But I won't be that picky with that today. It's mainly the process. So what does part B say? Calculate f prime of 2. Here's part A. Part B, f prime of 2 is nice and quick. It's just going to go put a 2 right here, and I'd have negative 1 over 1 squared, or negative 1. What does that mean? It means that function has a slope of negative 1. This looks a little messy. That's a 1 squared. It's like, what? That looks like 12. It's a 1 squared. So for part C, I'm supposed to use the alternative form of the derivative to find f prime of 2. So f prime of 2 could also be found by just doing the limit as x creeps up on 2 of f of x, it's the second definition, minus f of 2 over x minus 2. I better get the same thing, right? F of x was 1 over x minus 1. F of 2, go up here and put a 2 in, would be a 1. All over x minus 2. So it looks like I have to crisscross on the top. I'd have a limit as x approaches 2 of 1 minus, 1 minus x minus 1 all over x minus 1 collapse as a product over x minus 2. So on the top, it looks like I'm getting a 2 minus x on the top. That's what this is. It's 2 minus x. Let me erase some of this. Sorry, I don't have a whole lot of room on the bottom here. But that's 2 minus x. Let's distribute the negative, which is the opposite of x minus 2, so negative 1. So I end up with negative 1 over x minus 1, and x is approaching 2, so I get a negative 1. I got the same answer, okay, using both definitions. The first one's much more strong because I can put any x value in. The second one, the whole process leads me only to the derivative at 2. Let's go see what part D says. Confirm on your calculator. So here's what I want you to do on your calculator. First of all, graph the function. Now it's 1 over x minus 1, so it's going to have a vertical asymptote right down through here. It's going to go like this, and it's going to go like this. Then, I'm going to grab my calculator so I can talk you through. To confirm it on your calculator, once you have it graphed, so I'm going to go to my y equals, I'm going to graph the original function, which is 1 divided by parentheses x minus 1, and then I'm going to graph it. Zoom 6 if your window is out of order. All right, and you'll see this graph. To make your calculator take the derivative at x equals 2, what you do is you hit your math button. Or sorry, your second calc button. Sorry, second calc. So let's do second, and then calc is right above trace. So go second calc, and if you arrow down, you'll see number 6 says dy dx. This is also, you're going to learn notation for a derivative. So if you go hit enter, on the bottom it says at x equals. So it's going to have a little x equals, and if you put in a 2 there, it's going to tell you that the derivative is negative 1. Now mine says because remember this is a limit, so your calculator's struggling a little bit, but negative 1, it confirms our answer. So again, to do it on your calculator, go second calc, number 6, and then just enter the x value at which you're taking the derivative. All right, so that's it for notes, 13 minutes. Your assignment is to do number 1, number 2, you can skip number 3, do number 4, number 5, and then we're going to go talk about 7 and 8 together. It says, without using the, sorry, I put my calculator on my desk. It says, find the derivative. By the way, this is another piece of notation for the derivative. We'll introduce that in a little bit. But because this is a line, the slope of a line anywhere on the line is just 2. Because this is a line, the slope of the line anywhere is just 2/3. So we don't need any definition of the derivative to find slopes of lines. Nor, and just put slope is m in y equals mx plus b. Similarly, slope of a tangent line for any constant Well, y equals 5 is just up here. It's a horizontal line. And it doesn't matter at what value I'm finding the slope of the tangent line, because the slope anywhere along this constant line is just 0. M10 equals 0. So it says explain your results and use a graph as your explanation. So here you go. No matter where I go on a horizontal line, the line tangent to it is on it, and its slope is 0. Even though you might say, well, 2 pi, that's like 6-ish. So it's still going to be a horizontal line up at 6-ish. And anywhere along there, the slope is 0. So for homework, 1, 2, 3, 4, 5. You get stuck with the algebra, have the key help you. Have a good one, guys.